Okay, so we found our bus quiz. Here we go. We're going to see if we can get these set up. I think this is a really good review. So let's see what we still have questions about and what we can't figure out. So question number 1, here we go.
How far is this bus quiz?
The bus quiz actually goes on to the next page. There's 12 questions. How many 5-card hands from a standard deck have exactly 1 king, 3 queens? Okay, now wait a minute. Oh, my, the gang's all here. This is how many cards are in this hand? So if 1 is a king and 3 are queens, what is the other thing? Anything. All right. So here we can't be a king or a queen. It's something else.
Hey, John.
Now, how many ways can I get 1 king? Not 5C1. 4C1. Why 4C1? Because there's 4 kings, and you're picking 1 of them. How many ways can I get 3 queens?
4C3.
4C3. There's 4 queens. I want 3 of them. Now, how many cards are not kings or queens? 44. How do we know?
52.
52 altogether, minus 8 or minus 4 kings and 4 queens, right? So 44, and you want 1 of those. Now, what are you going to do with those 3 numbers? You're going to multiply them together. Now, you could easily type that in on your calculator. I'm not going to take the class time to do that, and we didn't have calculators on the bus, so we just set it up. But this is a setup. Multiply them all together. That will be your answer. Number 2, we got 15 boys and 10 girls. 15 boys, 10 girls. If 3 are selected, what is the probability of having exactly 2 boys? This is really a lot like the card problem. You want 2 boys. So what will that look like? 2 boys. 15C2. But wait a second. How many students are you picking all together?
3.
3. So this isn't enough, is it?
Enough.
You need 2 boys and
10C1.
1 girl. Now, this is a probability question, so it needs a denominator. What goes in the denominator of a probability question? The total. The total ways you can do something. How many total kids do you have?
25.
How many total kids are you picking?
3.
So your denominator is 25C3. Any question about that? What is the probability of guessing exactly 4 correct on a 10-question multiple choice quiz if each question has 4 options? Now think about this for a minute. We've done some like this. How do you want to start? 10C4. That's exactly right, Annabelle. And what's your logic there? 10, there's 10 questions, and you are going to choose 4 of them to get right. Now, what else do you need in the problem? That's not enough, obviously. What else do we need? We need the probability of 4 rights and 6 wrongs. Now, what's the probability of guessing correctly? 1/4. And then the probability of guessing incorrectly, that would be the answer to the question. In how many ways can a pitcher and a catcher be chosen from a team of 9 players? What'd you say? 9P2, very good, Gracie, 9P2. Why is this a P problem? It's a pitcher and a catcher, right? The order I pick you matters. You have different jobs. If I were just picking two, I don't know anything about baseball, outfielders, just in general, then I could use C. But if I'm assigning you specific jobs, it's gotta be P. How many ways can 7 books be arranged on a shelf if 3 of the books are identical? Not 6 factorial, not 4 factorial, 7 factorial. Why do we start with 7 factorial? Because there are 7 books. And I don't care what the details are. If there are 7 things and you are arranging them in a row, it's 7 factorial, period. Now, we're going to make adjustments to this, but we start with 7 factorial. When would it be 6 factorial? If we were putting them in a circle. Now, what adjustments do I have to make to this? I have to divide. And what do I have to divide by? 3 factorial. And why am I dividing by 3 factorial? Because there are duplicate books. Anytime you have identical things, and the example we did when we did this was with the letters of the word, remember? If there were 4 L's in the word, we had to divide by 4 factorial. These are duplicates. Anytime there are identical objects. How many ways can the letters of the word field trip, how many ways can the letters of the word field trip be arranged? Well, how do you start? Count. I don't care what letters there are there, that's irrelevant. How many are there? That's what we start with, 9 factorial. Then, we check to see if any of them are duplicated. Do we have doubles of anything? We have 2 I's. Is that all that's doubled? So that's it, 9 factorial over 2 factorial. Okay, there are 300 seniors, 240 take or have taken Precal. Of the Precal students, exactly half say they love vectors, 90 say they love matrices, and 70 say they love both. How many Precal students say they love neither vectors nor matrices? Are you thinking Venn diagram? When you read the problem, does it feel like a Venn diagram problem? So we'll draw a Venn diagram. Now there are 300 kids altogether. But in the circles, there are going to be 240. There are 60 kids out here that for some reason aren't involved in the problem, right? And of the remaining 240, they love vectors, or they love matrices, or they love both. So we've got 120 that love vectors, we got 90 that love matrices, and we got 70 that love both. Okay, where do I start? I start with the both. I'm going to fill this section in first. That's the overlapping section. Because the temptation is always to put 120 right here, and that's not right, right? We're not going to put 120 here. We're going to recognize that this whole circle is 120. So this has got to be 50, and this has got to be 20. Well, that's not right. Did I read this wrong? Yeah, I did. Because some of the pre-cal kids aren't included in the list. Okay, all right, so I got it now. All right, so how many kids are in the circles there? How many?
140.
Yeah, in the circles are only, this is the whole pot of pre-cal kids here, not all 300. The other 60, they're somewhere else. So these are the pre-cal kids, and we've accounted for 140 of them. So there are how many kids out here that are pre-calculus students, but they don't like vectors or matrices? There are 100 of them. There are 100 of them.
Why would they have extra students that don't even take pre-cal?
No, they don't like it.
Well,
Don't
I
you
don't
take
know.
60 off? Yeah, there's 300 seniors.
Yeah, and those 60 are part of the problem because
Yeah.
they're not, we're looking at just pre-cal kids.
Okay.
Yeah,
Just
so it's
a
just
trick,
extra
yeah.
information.
You would fall.
In how many ways can I award 3 identical prizes to my class of 39 students? 39C3. Why is that a C? Prizes are the same, so order doesn't matter. There's a 65% chance that Grant will come to pre-cal class on any given day. If he comes to class, there's a 74% chance that he will pass the quiz. If he doesn't come to class, there's a 12% chance he'll pass the quiz. Find the probability that Grant will not pass the quiz. What does this feel like? Does this feel like a tree diagram, a conditional probability problem? What are the 2 things that are happening in the problem? Coming to class and passing the quiz, right? Which one do I start with? At the top of the tree, use the one that doesn't depend on the other one. So of the 2 things, coming to class and passing the quiz, which one isn't dependent on the other? Coming to class. Coming to class is not dependent. Now, passing the quiz is. Now, what's the probability he'll come to class? 65. So there's a 35 that he won't. Now, if he comes to class, so here we are, if he comes to class, there's a 74% chance he'll pass, and then a 26 that he won't. If he doesn't come to class, there's a 12% chance he'll pass, and then an 88% chance he won't. This branch right here, 0.65 times 0.74, means there's a 48.1% chance that he will come to class and pass. That's what this branch means. Do you understand that? Okay, so then we have 0.65 times 0.26. This is the percent chance that he'll come to class and fail. There's if he doesn't come to class, he'll pass. There's a 4% chance of that. Now, the reason I went ahead and worked all these out, I always do, even though I rarely need them all in the answer, I always work them all out, because what did I tell you yesterday about these numbers? They have to add up to 1. These guys have to add up to 1. So that's kind of a check for you to make sure that you got it right. These numbers need to add up to 1. All right, so what's the answer to the question? Find the probability that Grant will not pass. So which numbers am I looking at? This one and this one. And what am I going to do with those 2 numbers? Add them. Because he can come to class and fail, or he cannot come to class and fail. Number 10, in how many ways can 4 boys and 3 girls be seated in a row?
So, yeah.
7 factorial, period. Does it say anything about, are there any stipulations? Like, do the boys have to be together, or the girls have to be doing this, or something like that? No. What have you got? You got 7 kids. How many ways can you seat 7 kids in a row? 7 factorial. Now, if we said, it doesn't say here, but if we said, we've got 4 boys, 3 girls, we're gonna put them in a row and the girls are together, that would be a different problem. We would approach that differently. Because if the girls have to be kept together, then they don't function independently. They don't function like 3, they function only like 1. So if you had 4 boys and a clump of girls, how many ways could you arrange those? 5 factorial. But you remember what else you have to take into account? 3 factorial. Because when you tied a string around those 3, you could have done it 3 factorial ways. That is not the answer to the question on the paper. The answer to the question on the paper is 7 factorial. How many ways can you arrange 15 students around the tree being planted on the field trip? 14 factorial. Oh, here we go, number 12. In how many ways can you, I think that should be seat, 3 algebra students. So we have 3 algebra students
Okay. This is where we need to shine.
and 6 pre-cal students in a row if the algebra students have to be seated together. 7 factorial, 3 factorial, perfect. What if we said the students of each subject had to be seated together? So all the algebra together and all the pre-cal together. What would that look like? 2 factorial for the 2 bundles, and then 6 factorial, 3 factorial for the individual within the bundles. Okay, that's a pretty good review. Good, good, good. Did anybody have a question about a homework problem?
I have a question about just on a test or something, would we leave it as like 7 factorial or we just get it out? Okay.
Okay, so let's see, did everybody show up? Why are we all late today?
Are you coming tonight?
Okay, anybody have a question about a homework problem? 25.
All I heard was mine had been hard to strata.
This one's mad for everyone.
Not a matter.
Is this the one that says we have a hand that includes all 4 aces?
Yeah, that's gonna be a problem.
Okay. Listen, we're doing number 25 from the homework. Now, this is a different situation. This is a different kind of weird card game. The deck contains only 24 cards. And the hand is 6. So we're going to have a 6-card hand. The deck contains only 24. And we want the hand to have all 4 aces. So that would be 4 aces and then 2 not aces. Right, because it's a 6-card hand. Well, how many aces are there in our deck? 4. And I'm picking all 4 of them. I need all 4 aces. So 4 total, I'm choosing 4. And, so I'll multiply, 2 not aces. Well, remember, this deck only had 24 cards in it. 4 of them were aces, leaving me with how many other cards? 20, and I am choosing 2 of those. Now, was that a probability question? So the denominator, this is what I want. So this is my numerator. The denominator in this problem, in all these problems, any problem associated with this scenario, the denominator is going to be 24C6 because there are 24 total cards and you are picking 6 of them. Does that make sense? Yeah. Anybody else have a question from the homework? Stephen Stark. I know this is a big day for you, but I need you to turn around and pay attention.
Heidi's the only one that knows.
Me too.
Chill, guys. Chill.
Hey, listen, I don't want all that on video. Okay?
Yeah, you should ask her doing the videos.
Our pay attention, our pay attention.
That would be kind of funny if someone did that on like the video.
We're going to have a problem proposal in one of my classes today. I'm excited about it. Okay, so who has a question about a homework problem? Anybody? Yes, Jessica. 34. Number 34. Okay. Here's the deal. We have a bunch of calculators, and some of them are defective, and some of them aren't. The probability of choosing a defective calculator is 0.037. The probability then of choosing a non-defective calculator would be, oh, watch my arithmetic here, 0.963. I am going to choose 4 calculators, and I want all of them to be not defective. I want them all to be good calculators, okay? So I'm going to choose 4, and I want 4 of them to be good. So that would be 4C4. There are 4 picks, and all of them are going to be good calculators. So I want 4 good ones and no bad ones. Well, what's the probability of being a good calculator? 0.963. And the probability of being a bad calculator is 0.037. So that would be the setup for the problem. This is like guessing on that multiple choice question. When you guess, you're right or wrong. When I pick a calculator, it's either good or bad. And then I pick another one, it's either good or bad. Okay? Anybody else from the homework?
That was me, not Steven. My bad.
All right, tonight's homework then, let's get started on that, is the pretest that is in your packet. Now, I'm going to give you a break. On your test, you will be working them out and getting actual answers. As long as you are comfortable and know this is where I can type this in on my calculator, then you don't have to practice it. You don't have to do it. There's a lot of problems on this pretest. So you do not have to type them all in and get actual answers. You can just set them all up. as long as you understand on test day, you'll be typing them all in. So practice as much as you need with your calculator. You do not have to type all these in. Why don't you take a skim down through there, and I'll let you go ahead and get started while we're just still working. Take a skim down through, no, it is called pretest. Take a skim down through it. Are there any there that look like they might cause you trouble?
Oh. Here we go, here we go, here we go.
Find the 10th term of the expansion. Okay, does anybody recall, we spent a day talking about this, does anybody recall how we did this? I think we did it last Thursday. We can use Pascal's triangle. But I really don't want to on this problem because since it's to the 12th power, I would have to write the triangle out to the 12th row, which I could do, but it takes forever. So then I remember, wait a minute, the numbers in the 12th row are the combination numbers. So the first number would be 12C12, 12C11, 12C10, 12C9, 12C8. Which one do I want? The 10th, oh Lord, the 10th term. So 12C7, 12C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 12C3. Did I count right? Would that be the 10th term? That is not the answer. Next, that's the coefficient of the answer. Next, or the binomial coefficient, I should say, not the final coefficient. Next to this will be 2x and negative y to some power. Remember this? How's come 2x and negative y? Because those are the things in the problem. Now, if we were writing out the whole thing, there'd be a 2x and a negative y next to each of these. And the power on the 2x in the first term would be what? In the first term, the power on the 2x would be 12. And then they go down. So this one would be 11, 10, 9, 8, 7. So the power on the 2x down there is going to be 3. And since this problem was to the 12th power, if that's a 3, this is going to be a 9. Can somebody tell me what 12C3 is? 220. Now, I got 220, that's this. Now what's 2x to the third? 8x cubed. And what's going to happen with this negative? Stays negative. So I'm going to end up with negative 1760 x cubed y to the 9th if I times right. Remember doing that?
220 times 8.
All right, skim through. Anything else we need to talk about before we, Seven. How many diagonals does a regular hexagon have?
Could be looking up forever.
Wait a minute, where's that question coming from?
What?
How many diagonals does a regular hexagon have? What's it mean to be a regular hexagon? It means there's 6 sides and they're all equal. Yeah, they're all the same size. Okay. How many diagonals does it have? Okay, now let's think about this for a minute. A diagonal joins 2 points of the hexagon, right? That would be a diagonal. And this would be a diagonal. and this would be a diagonal. And this would be a diagonal, and this would be a diagonal. I could go through and draw them all and count them up. There aren't that many, so that would be an option. But let's think about this for a minute. What I'm really doing is joining these points 2 at a time, right? Picking 2 points and drawing a line between them. How many points are there? 6. And I'm picking 2 at a time to connect. Does the order I draw them matter? In other words, does it matter if I go from here to here or from here to here? No. So 6C2? Now be careful. That is joining any 2 of the 6 points. Subtract the sides. Bingo. This would be the way to do it if you didn't want to just count them up. Absolutely, you could draw them and count them up. Do you understand why we had to subtract 6? Because when I join these 2 points, is that a diagonal? No. So if you say to me, I'm going to join all the points, all the pairs of points, that's absolutely great. But then you got to take out the ones that aren't diagonal. So there's 6 of them. So what if this had been an octagon? 8C2 minus 8. Or draw it, connect them, count them. Anything else you see on here? All right, then you've got, I forget, like 10 minutes maybe to get started on this worksheet. This is your homework. There are a lot of problems. Stephen?